So this part matches with this part, then this solution is given by this. In our case, m is 1 and v is 1 minus e raised to z the whole raised to minus 2. So this d plus 1 will remain as it is, and here this thing will be replaced by this part, which is e raised to minus m into z. M in our case is 1, so e raised to z. Integration of opposite of this is e raised to z into v is 1 minus e raised to z the whole raised to minus 2 dz. Now we have to perform the integration of this part, so consider this integration only. So integration of e raised to z 1 minus e raised to z the whole raised to minus 2 dz. If we assume this equal to f of z, so our f of z is 1 minus e raised to z, then our f dash of z will be 0 minus e raised to z, which is minus e raised to z. So I am multiplying minus, so this will be our minus e raised to z, which is f dash of z. So this integration is nothing but integration of f of z the whole raised to n plus 1 into f dash of z into dz. So whenever we have this type of integration, we have direct property which, so this integration is nothing but is of the form of f of z the whole raised to n into f dash of z dz. So whenever we have this type of integration, we have one direct formula, that is f of z the whole raised to n plus 1 upon n plus 1. So this is the direct formula whenever we have this type of integration, and this integration exactly matches with this type. So the answer of this integration will be minus this minus sign, and we are going to apply this formula. So in our case, f of z is 1 minus e raised to z the whole raised to n plus 1. In our case, n is minus 2, so n plus 1 will be minus 1. So 1 minus e raised to z minus 1 upon minus 1. So this minus and minus sign will become plus. Integration of this part will be 1 minus e raised to z the whole raised to minus 1. So this e raised to minus z will remain as it is, and this part is 1 minus e raised to z the whole raised to minus 1. So our yp now become 1 upon d plus 1 e raised to minus z 1 minus e raised to z the whole raised to minus 1. So if you see this equation is also of the form of 1 upon d plus m into v. In our case, m is also 1 and v is this part. So again we are going to apply the same formula. So e raised to minus m z, m is 1, so e raised to z, integration of opposite of this, which is e raised to z, multiply by v is e raised to minus z 1 minus e raised to z the whole raised to minus 1 into dz. This part will become 1 and we get e raised to minus z integration of 1 upon 1 minus e raised to z dz. I am taking this in the denominator. So we know that e raised to z is nothing but 1 upon e raised to minus z. We can write in this way also, e raised to z is 1 upon e raised to minus z. So here we will replace e raised to z by 1 upon e raised to minus z, which is nothing but e raised to z. After this we cross multiply. So we get e raised to minus z integration of 1 upon e raised to minus z minus 1 upon e raised to minus z dz. Now this e raised to minus z will go in the numerator. So now this is our new integration. I am also multiplying this by minus and 1 minus here. So minus and minus will become plus. Why I am doing this, you will come to know about this very shortly. So I will assume this part as f of z. So my f of z is e raised to minus z minus 1. Then f dash of z will be derivative of e raised to minus z is my e raised to minus z, and derivative of minus z is minus 1, and derivative of minus 1 is 0. So the derivative of f of z is minus e raised to minus z, which is the numerator. So the numerator is f dash of z and denominator is f of z. So the integration of f dash of z upon f of z is nothing but, here we will use the direct property, which is nothing but log of f of z. And so that's why we have multiplied minus sign. So minus e raised to minus z, and integration of this will be nothing but log of f of z. In our case, f of z is e raised to minus z minus 1. So this is our yp. Then the final solution will be given by y equal to yc plus yp. So this is how we solve the problem on higher order differential equation with variable coefficients. More such problems we will see in our next video. So stay tuned for our future lectures.